In case you did not understand the solutions in class, here they are again. Hopefully this will help you. So step number 1, so a ball is thrown downward with an initial speed of 20 meters per second on Earth, and task A is to make a well-labeled diagram of the situation. And I highly recommend, regardless of whether or not the problem says make a diagram, that it will always help you understand the problem better to write or to make a diagram of the situation. And if you can't make a diagram, that means you don't understand it, and so there's really no point in starting the problem. So I've got a ball, it's being thrown downward at 20 meters per second, and for me down is always negative, and so this is my diagram and my label. And I should probably even say V0 is that. Next thing, again, whether or not the problem specifies it, you should always make a variable list and always use the same set of variables. So I've got Vy, I've got V0y, I've got Vy, I've got Ay, and I've got t. Now previously we have not put x's or y's next to my velocities or accelerations because we were only moving in one dimension, but for this unit we are moving in 2 dimensions, and so that's why I'm adding this extra index so that I know I'm talking specifically about the y or vertical direction. So I don't know what y is. I know that my V0y is negative 20 meters per second. I don't know my final velocity. I do know that my acceleration in the y direction is the acceleration due to gravity, so that's minus 10 meters per second. And my time, I don't know that either. So these are the variables that I know so far. And then the acceleration of the ball is minus 10 meters per second per second. Okay, so every problem should start out, whether or not it specifies it, with a diagram as said in A and the list of variables as said in B. So calculate the displacement during the first 4 seconds. So displacement, I'm going to use the displacement formula. So that's y is V0y t. I'm going to just make that 0 a little bit smaller. Plus 1/2 ay t squared. And so I know from the problem that V0y is negative 20 meters per second, and t is 4 seconds. And then my ay is minus 10 meters per second, and t is still 4 seconds, and I'm going to square that. And when I calculate it, I should get minus 160 meters. Calculate the time required to reach a speed of 50 meters per second. I forgot to mention this on task D, but you always want to write your equation in variable form first. Again, it's just part of the problem solving method that will always lead to success. So here I've got a final velocity. I know my initial velocity, and so I'm going to use this equation. And since I want to know time, I'm going to solve for time. And now I'm just going to plug in my values. So Vy is going to be minus 50 meters per second. It's negative because the ball is moving down. I've got a subtraction sign because that's what the algebra gives me. And then I plug in the value, and that's minus 20 meters per second. So this negative sign is from the algebra, and this one is because the ball is thrown down. And again, this negative sign is because the ball is moving downwards. And then A is negative 10 meters per second because the acceleration due to gravity is down, and for me that is negative. So this is equal to t, and it's equal to 3 seconds.